Hey guys, welcome to Podcast. In this session, we'll discuss the topic the error handling, and we'll see how why we use error handling and the basic tracks and blocks how we can use to handle the error. Now, starting with the topic that is the error handling, we should always remember it is used to for writing the safe and reliable code. And when we discuss with the error handling, sometimes you guys may have come with an error like that code runs into problems like dividing by zero or opening a missing file. So at that point of time, you will get an error while after running the cell. So error handling helps you catch and respond to these problems instead of crashing the program. And in Python, we use the try except block for error handling. Now the try block encloses code that might potentially raise an error during the execution. So whenever you think that a particular line of code or particular code will be crashing or will be potentially raising an error, then that code will be involved in the try block. Okay. And what is the and if an error occurs within the try block, Python looks for a matching except block to handle it. Now, for simple example, suppose I know that when I divide any number by zero, I will get an error, right? So what I will do, I will just mention in the try block that suppose x is equal to 10 divided by zero. I know that error will happen, and so what we'll do instead of crashing or instead of running any error, so what I'll do, I'll just mention the except block and I'll mention the print suppose an error occurred. So in this way, it keeps your program from crashing. That is the except block. Now handling specific exceptions, that is the targeted responses. Instead of catching all errors, except blocks can specify the particular type of exception they handle. So example, we got an value error or type error. So at that point of time, we can also mention the what we can say exception type, and this allows for different more appropriate recovery actions depending on the specific error encounter. So catching specific errors helps you write better and clearer responses. Okay. Now suppose in try block I type num is equal to int of hello. So I cannot make a string value into integer, so that naturally it will raise an error. So in the except, while defining the except block, I'll just mention except value errors and print you must enter a valid number. So in this way we can catch the specific errors and it will help us write better and clearer responses. Now the else clause, that is the code for a success. An optional else clause can be added after all except block in a try except success. The code within the else block is executed only if the try block completes without raising an X. Now suppose in the I wanted to divide 5 by 1. So in try block I will mention that x is equal to 5 divided by 1. Now in except block I will mention the error also, that is the zero division error, and then I'll print you can't divide it by 0, but it is actually dividing by 1. So in else block, I'll mention another block, else block, I'll print division successful. So we can also use the else block, which will the code that runs will when no error happens. And the code within the else block, the code within the else block is executed only if the try block complete without raising an exception. So if try block is not raising an exception, so naturally the except block will not what we can say work, and so the else block will naturally be executed. Now the finally clause which always runs and it is for cleanup code. So use finally to close file or release resources or perform cleanup no matter what. So the finally clause, if present, contains code that will always be executed regardless whether an exception around in the try block or not. And this is crucial for cleanup operations such as closing files or releasing external resources to ensure they always happen. I'll do a simple what we can say. Let's imagine a simple try except and finally. So in the first of all in the try block, I will mention the file is equal to open and I'll mention some file name. Next step block, I'll give the file not found error and I'll print file not found. And finally, so I will in finally block, I will just print that the finished trying to open the file. So it is finally generally used to close file or release the resources or performance cleanup. So at that point of time, we need to use the finally clause. Now raising exceptions, signaling problems proactively. The raise statement allows the programmer to deliberately trigger an exception at a certain point in the code, and this is useful for indicating that an error condition or invalid state has been detected by a program logic. So we are definitely what we can say defining the error, and so for example, suppose I define a function. Suppose I define a function named divide. I'm passing two values a comma b. Now I'm dividing a by b. Okay, and I know that if a is divided by 0, then we will generally get an error. So what I'll do in if block, I'll mention it b equal to 0, then raise, that is the value which we are dividing by is 0, and we will raise value error that we cannot divide by 0, and then we'll return a comma. So use raise when you want to stop the program on purpose due to a problem. So at that point of time, you need to use the raise. Now we'll see the summary after what points have we learned from the slides, that we use the try except block to handle error safely, and we use to catch specific errors like the value error or the zero division error, and use else for successful runs, or use final it for cleanup no matter what, and use raise to create your own exception. So I hope you guys understood the theoretical part, and in the next part of the session, we will move towards the implementation where you will get the better understanding of the topic error handling.